Powerful severe weather setup is currently beginning over parts of Arkansas, Mississippi, Missouri, and Alabama, especially for day 5 and day 6. So that's going to be next Friday and next Saturday. Now this is a pretty new event. We got a day 7, or I believe it's a day 6 slight risk here, somewhere in this vicinity. And with our day 5 and day 6 now, these have now been upgraded to 30% at day 5 and day 6. So this Storm Prediction Center is already issuing pretty intense severe weather outlooks for this period. I'll be looking at a few different products, trying to understand this event for you guys. Also, remember this is a few days out still, and there's so much uncertainty behind these, but models are beginning to come to a consensus. So let's begin. First of all, I want to look at something interesting. I look at this oftentimes in events that are in the future. This is the Colorado State University Machine Learning Program. So basically what this does is takes a lot of data from the past and looks at probabilities of severe weather. And this has been found to actually have more accuracy than long-term SPC outlooks a lot of the time. So we're just going to look at what this is hinting at. You can see for Friday, which is our day 5 outlook, we have a pretty broad what would be equal to an enhanced risk on an SPC page. Obviously very similar to what we have here, except this machine learning program has a lot larger of an area, also with more northward extent. Looking at day 6 as well, you can see it has this hatched region here as well. I believe this is a 50% probabilities at maximum here. You can see that would be equivalent to a moderate risk at day 6. Very intense probabilities from the machine learning program. Obviously, this is still experimental in some regards, and it is based on AI. However, I did want to look at this just because it often can really hint at what you're going to be seeing in the future. Something else I haven't shown in this channel before, this is called a chiclet chart, and this shows kind of severe weather probabilities. The main thing on this graph is actually supercell composite. This comes from the CFS, which is a very long-term model. You'll see it on College View page sometimes. You'll end up with, it goes very far out. Let's go to the 0Z run of this thing. Yeah, this thing goes out all the way. Let me see. Give me a second to load. I mean, this is April already that we're in. This goes out almost 800 frames. It looks like all the way to April 12th, and you'll see this one will look like this one even goes even further. So essentially, what this is you have time on this axis. And what you want to see for severe weather is a signal going over a few days. This was last week's severe weather event. I made a video on it at one point and didn't have a chance to do it again. But you can see how this progressed with time. You had multiple days where this signal of supercell composite would come back up on this chart. And you can see for our 14th and our 15th, which is that Friday and Saturday, you can see a really big spike in the mean, or the median there. And you can see this has been really going on with a lot of time. You can see this signal has been persisting for multiple runs now. At least eight runs, I believe. You can see on the left side here. So this signal has been here for a while. It's been persisting, and that gives us even more confidence on this event. Now let's look at the specifics of this thing and see what we're really looking at. This is day 5 and day 6, so the models I'll be using is the GFS Ensemble, and the European model, just to kind of compare. Let's look at our Ensemble GFS model. So again, we're looking at Friday and Saturday, and one thing I did want to mention as well is Wednesday's event, we have a little bit of a shortwave trough. So we look at this SPC page. Wednesday has a little marginal risk. Our CSU, we have this slight risk looking thing. You can see a little bit of severe weather. It's talking about a shortwave going on. You can see our GFS Ensemble really hints at this. This is also apparent on the NAM. You have this little bit of a shortwave trough. I have noticed this has been progressing differently on different runs. So looking at our 0Z run of the GFS Ensemble, you can see pretty well defined trough, but a 5580 contour here stays more up north near Kansas. The 6Z model also shows something similar. With our incoming 12Z, you can see this actually dips down further. This could have an impact on the day 5 and day 6 event, the bigger event we talked about, because this is going to get rid of a lot of moisture, and we'll talk about that in a second. But looking at our GFS run, obviously you can see very clear we have a closed low here. Compared to the last run, we do not have that closed low, so it's possible we're hinting towards something more similar to that style. Now let's look at the GFS. Let's pivot over here. Again, this is our current setup. We have a little bit of a trough going on. This is actually associated with the slight marginal risk in Florida. But as this goes on, we get this little bit of a short wave, and then you can see back here we have this deepening trough. And that's going to be our main event for Friday and Saturday. Very deep digging trough. The GFS has been really hinting towards, not hinting, but showing this very strong deepening of this trough. You can see very strong winds at the base of this, surrounding the base, very negatively tilted. Basically what you would expect to see with severe weather. You have a lot of divergence here. Oh, it's a bad color. Lots of divergence where you'd want it. You can see we have southwesterly flows here, much more westerly. You can see these barbs. This barb is westerly, a little more westerly. So we have some divergence in this region. You can really see it up north here on the contour lines as well. Lots of divergence up there. And of course, the very strong flow in the pink colors you see there. Not to mention the very, very strong closed low with two different contours away from the actual low and the negative tilt of it. It looks like a very potent trough, and frankly, it is. It also has a lot of vorticity surrounding the base as well, which means you're going to get a very strong surface cyclone here. You can see how large this thing is. There's not really a better sector. Let's go to the Midwest just so you can see how strong these winds are. You've really widespread 20s, let's see, 21, 20 knot flow basically everywhere here over the Midwest. This is actually gonna be a really big issue for winds. This has been some discussions I've seen on the internet of pretty intense wind gusts up to 45 miles an hour possible. So throughout the entire day, and very strong winds for the Midwest especially. But you can see here again, so much southerly flow, maybe even easterly, and you can see our temperatures are pretty high. However, the one thing with this setup that's really kind of lacking is going to be our dew points. So let's look at our dew points right now. You can see we definitely have a pretty broad moisture return, but that first trough I talked about that would be passing through, again, we'll back to 500 millibars here. You can see there's our shortwave trough. This is actually going to get rid of some of our moisture. So let's just watch how this loop goes through. Here's 12Z that same day. You have moisture reaching up pretty far. 40s going all the way up into Illinois, parts of Iowa, Indiana, Ohio River Valley, kind of. But as this next trough comes through, you can see you have this instability indicated by these lifted indexes here. However, this moisture, not as much of it goes up north, and you can see some of it gets pushed out here. You can see by the drier amounts. Let's look at relative humidity. Just going to be a good indicator for this setup is relative humidity. You can see again, Wednesday, we have a good amount of moisture in there. The day after, it's a little bit more lacking. You see a lot more of those browns in there. That's for Thursday that you end up with more of the brown colors. And then Friday, and you still have some moisture sitting around, but not nearly as intense as you'd like to see. The kind of setup you'd like to see is, you want to see this trough very slowly moving, leading to a lot of southerly flow from the Gulf over a large span of time. However, because of this trough, it's going to push out some of that moisture. So we are looking at that, and that could be its own issue. And that's partially why I want to talk about this Friday setup in particular, because it is kind of interesting in that regard. Here's 21Z on Friday, 4 p.m. Central. If you're in this region, you'll be in Central Time. And if you look at our dew points, again, we have pretty large 50s overspreading the region. Let's look at the 12Z GFS and see how that changes, actually. Looks like the 12Z GFS actually brings down the moisture a little bit. Very interesting. But yeah, if we look at our relative humidity, we have about 50%. Not the best thing you'd want to see for severe weather. You want to see higher dew point values, especially if we're thinking tornadoes. I'm going to take a sounding just so you can see how dry this air really is. So take a look at this QT and you'll really see what I'm talking about. See how dry this air is. So this is going to lead to not really surface-based storms like you'd like to see. And also, do keep in mind this is a 21Z sounding, so the better thermodynamics might be later on in the evening hours. But you can see here how dry this air is, right? The highest LFC could be somewhere around here, but yeah, that's the LCL, even if you just follow the dry bat in our mixing ratio. LCL somewhere in this vicinity, you can see it's indicated there by the green, but that's over a kilometer up in the atmosphere, which is pretty high if you want to talk about tornadoes. This could lead to stronger downburst. D cape is at 934, and compared to our surface-based cape of 1454, that's pretty strong. So we could have some more gusty style winds out of stuff like this. That's something to keep in mind. And elevated storms could lead to more hail threat rather than tornadoes. However, look down south, we're going to have a lot more moisture. You'll see this on relative humidity as well. Louisiana here, a lot more moisture. You can really see those greens start to pop up a little better in the overnight hours. If we look at our dew point especially here, again, much better dew points. We're in the 60s here, a broad region of 60s dew points. So in some regard, the thermodynamic profile looks a lot better if you're more in the south, more in Louisiana and Mississippi, parts of Arkansas. However, our kinematics are much more supportive if you're in the northern mode here. We can see a lot more stronger flow, parts of Missouri, parts of Arkansas, Illinois even. You have a lot more divergence, even 250 millibars as well. Yeah, lots of divergence up here. Let's actually zoom out. Um, yeah, lots of more divergence up north, it looks like. So the kinematics do play a little bit more of a role in the north, although you can see, again, a lot stronger flow at 250 millibars. 500 millibar jet streak ends up being more up north, and you have stronger jets up there. 850 millibars as well. You can see that 850 jet, lower level jet, is a lot stronger. Here's 0Z, pretty strong jet up here in Illinois, Missouri, and not so much in the south. So you could say the kinematics are much more in play in the north, and the thermodynamics are much more in play in the south. That kind of leads you to end up in this sweet spot right here, somewhere around here where you get a little bit of both, right? You get some of the good kinematics of the north part and more of the thermodynamics, and especially moisture in the southern mode. So that's something to keep in mind, and also the fact that our mean wind is going to be more northern or southerly if you're in northern regions here, right? So here's our bulk shear also, by the way. Again, this really shows that kinematics. You have a lot better kinematics in regions Missouri and Arkansas here. We're not going to count this part because there's really bad moisture and there's not really potential for severe weather back there. But yeah, better kinematics again, as we talked about. There's 21Z again, just a lot better shear up here. However, again, they talked about you got to pay attention to our mean winds. We looked at the bulk shear, a lot stronger up here, a little weaker down here. Let's look at storm motion through mean layer cape. If we compare the two, let's look at the Midwest here. See, our storm motion's a lot more north, to the north, not northerly, but to the north here. Regions closer to our frontal boundaries at the surface are actually pretty close to the frontal boundary. It's hard to draw a frontal boundary. Let's look at the dew point. That'll probably show it a little better. Let's see, let's choose 0Z here. 0Z will put a kind of a cold front right here. So let's see how our storm motion vectors look compared to this. And you'll see we have a lot more parallel to the boundary, some perpendicularity, but it looks like our perpendicularity ends up being more so down here, where you kind of have this boundary. Let's continue the boundary a little bit more. Yeah, so we'd have a kind of cold front somewhere in here. But you can see that we have a lot more perpendicularity if we go further down south, and that's better for discrete storms. Might be looking, again, as I said, more at wind risks up here in Illinois and Missouri, and with more discrete cells being noted, especially in the SBC page as well, down here near Arkansas. You can see how perpendicular these are. These are easterly flow here. The bulk, the mean wind here. It's like our storm motion as well, a lot slower down here, which could be an issue if you want to keep storms discrete. If the cold front is fast enough, it could catch up. Let's see, dew points. Yeah, looks like our front is pretty well defined down here, somewhere in this vicinity. And if we look at our vectors here again, yeah, right off that boundary pretty well. So we could have a little bit more of a mixed mode. We can definitely see why the SBC is putting this. Oops, there it is. Putting this enhanced risk in that region here. Ignore the line for a second. You can see definitely Arkansas is being noted. This little region right here is where they are talking about. If you go frame back again, you can see we really get that perpendicular component from 21 to 0Z here. Want to be simplistic, we can look at supercell composite. Let's just zoom out 100% here. Look at CONUS. Let the data load a second. But you can see here's Friday at 12Z. See the progression, right? You get some storm development likely up here with enhanced supercell composite, and then that moves down south as time goes on there. Surface-based cape again, it's a decent measurement as well. You can see instability really starts to rise up here in our more northern section, but again, you can see here some capping seems to stay in place until you hit 21Z. At that point, you might have issues with storm mode, so that is something to be keeping in mind. Instability is going to be a lot easier down south where you have that better moisture. So there's not really many other specifics I can look at here. Looking at low-level lapse rates actually is a little bit interesting, and you can see we have lower low-level lapse rates, which usually doesn't sound good. However, in our case, the lower-level lapse rates being high actually indicates a lot drier air mass. You can see we have a lot more moisture down here. We talked about that. Looking at dew point, The one thing to keep in mind, we might want to pay attention to this plume of moisture that keeps being shown. Here's our Wednesday trough that moves through, and it looks like some of that moisture actually stays up here. So that's something we're going to have to keep in mind. Again, if there's anything to get from what I'm saying right now, we have to monitor moisture in this case. It's going to be a big issue, possible inhibiting factor, but also it's going to be really, really important for where we have a tornadic risk area versus where we have hail risk or wind risk. Let's move on to the day 6 outlook. Again, we can see this trough will begin to occlude Saturday night. You can also see we have a little better warmth here, possibly better moisture content also as this trough begins to occlude, and that could preclude some tornado risk on Friday night as well, and up here in the Midwest. Looking down south, you can see very clear. It's very typical in that sense for the south, where you get this event. We have this little bit of a trough. It begins to stall out a little bit. You can see our flow is a lot weaker here, right? So we talked about 20 plus knots. Down here we have more so 10 knot flow, a little bit weaker of a low pressure system down here, and this leads to a kind of stalled out area of moisture. Because we still have this southerly flow from the Gulf, you can see here on Saturday here, pretty good southerly flow. I will say there is some questionability with the way the GFS run really shows all this. I believe it gets a little bit contaminated by convection here. But you can see at 18Z, we have a lot of moisture, very humid, pretty good southerly flow, a little bit veered, but in either case, we do have a good amount of flow. You can see even possible cyclogenesis here again. I don't really see why it would occur synoptically, but the GFS has been hinting for some reason that we get a little bit of a shortwave here, maybe helping to, yeah, you can see on the 700 a little bit of a kink in the contour lines. And kind of strange to me. I'm not sure how much I trust that, but you do get a little bit of enhanced 850 flow, it looks like, and that might help to begin in a little bit of cyclogenesis, just enough to kickstart an event here. As I talked about, moisture is a lot better down here. Let's look at instability here. Here's 21Z. You can see a lot better instability down here in Louisiana. Let's take a sounding from there, actually. And we'll take a sounding from, let's just take an area here in Alabama. Let's go right there, southeast Alabama. Here is our Louisiana setup. You can really see how good of a hodograph, how good of a SQT. Thermodynamics look really good. Hodograph, there is a little bit of desire. You'd wish to have a little bit more of an easterly component at the surface, but either way, you do have a pretty good storm relative hodograph there. Plenty of varying with height. Thermodynamics look really good as well, and pretty good lapse rates, 7 degrees Celsius per kilometer. So definitely more extreme than the moist adiabatic lapse rate. Decape here, it looks like about 1100, but when you have about 3400 joules per kilogram of surface-based cape, that really changes a little bit. So this looks like a pretty volatile environment for severe weather down here. The Alabama setup, let's see, here's our Alabama SQT. Again, it could be a little bit better, as we said with Louisiana, but we do have a little more southerly component here. A little bit better 0 to 3 shear. But effective bulk shear, about 50 knots. So pretty nice. SRH values are also near the 200s, which is pretty good. 3 cape also here. In either case, you actually have a good amount of 3 cape. Here's a Louisiana, about 85, 90 in Alabama. So thermodynamics for Saturday look a lot better. I'd be a little bit more inclined to believe that that day will look a little more severe. Let's go forward. Yeah, you can see instability really just stays in play a while here. Yeah, so this looks like a more volatile day on Saturday than Friday. Friday looks like a little bit more coverage, which often is more dangerous. So regarding that, we don't really have much else to look at. Again, you can see our day 6 outlook here. I forgot to show this again, but that 30% goes over regions of Alabama and Mississippi. I believe we might see this get a little bit more expanded into Louisiana. We'll have to see that and monitor that again. Louisiana just has a lot more instability, especially according to this GFS. Let's look at the Euro now, actually. Let's go down south here, see what the Euro's up to. By the way, this is most unstable, so it might look a little more extreme. That's okay. Actually, European model has a little bit more instability on Friday over there in Texas. And it looks like a little bit less in the Midwest. This is our Friday event here. A little more widespread instability. I can't take soundings, unfortunately. Moisture content on the European model looks a little bit more favorable. I mean, you can see we actually get a little bit of 60s plume on Friday in regions down here. A little deeper moisture as well. Same thing here though, a very strong cyclone it's looking at. Let's compare the 12Z on both the Euro and the GFS here. See how they differ, how they line up. There's 12Z. So we have this pretty volatile trough, as we talked about. GFS progresses this a little bit more, it looks like. So GFS is more progressive than the European model. And does show we have some uncertainty still. This is day 5, so there's plenty. We have to let time take its toll. But yeah, let's see. Yeah, definitely a little more progressive. Let's look at our 12Z GFS. Deepens the low. The European does not deepen its low as much. Let's look at 18Z now. Let's look at 21Z. That's usually our big frame. GFS, yeah, a lot more progressive as we talked about here. Very similar story in both cases. The GFS just has us a little bit further to the northeast, which again could very much change how this event is to play out. Here's our moisture content from the European model. GFS, notable difference right there actually. So here's our moisture content from the same 6C run of both of them. GFS is a little bit more constrained. It doesn't like to go as far on the moisture return. GFS shows a much larger area, especially in the south here. Parts of Texas getting very humid on the European model compared to the GFS where you have this cold front really beginning to blast off. And that makes sense, right? Look at our 500 millibar map here at the GFS. You can see this is already beginning to occlude here. Actually, temperatures wise also. Let's see. Yeah, you can see it begins to occlude there a little bit. It takes a much more northward track. The European models, I believe, goes more easterly rather than northerly, it looks like. Yeah, and the European model goes to occlude a little bit later on. Actually could have an interesting impact on this one. Looks a little more cold core rather than GFS, it looks like. Interesting difference right there. So, we'll have to keep monitoring this. Very important to keep monitoring this setup. Yeah, look at all that. Just very interesting differences there. The GFS ensemble does not give me moisture, but very interesting difference there. Yeah. So that's something to keep in mind. Again, if there's anything to get from this outlook that I'm talking about, this is the video in general, there is still uncertainty this event, but as of right now, the cards do seem to be lining up. We looked at our machine learning program. I'm especially worried about how significant it's looking on Saturday. I'm curious how that will play out. And also just the risk areas that we're going to see tomorrow. I'll try to keep updating you all. I have some time to make videos now, which is very nice, at least for this week. So I'll have time to update you guys on these events. But if there's anything to get from this video, it is that there is still uncertainty, but our cards are beginning to line up. We are starting to see some similarities, especially between the GFS and the European model. So please do keep this in mind that this is not certain. There's so much time to still change this event, so don't go freaking out all about it quite yet. Anything could change. Last time we had I think it was a day 6 enhanced risk for our last event in the southeast, and it stated enhanced risk, very good day 6 outlook, but it did not become nearly as significant as people believed. We had some inhibiting factors come into play, and that really changed how that event went. But either way, this does look to be a pretty significant event. I'm going to keep monitoring how this will progress. We'll see if any of these risk areas get changed at all. I'll be paying a special attention to the Midwest as well, just to see if I can see anything living in the Midwest. So with that, that's about it for this video. Again, take what I have with a grain of salt. There's still plenty of time to change how this event begins and how it progresses. But it does look to be setting up to be a pretty significant event and something to be worried about. So thank you all for watching. If you like these videos, please let me know down in the comments, or if any feedback, anything you want to see in particular, any video ideas, really anything. Any feedback is great, and I will take it to heart. So thank you for watching, and I will see you all next time.